It's just a bit of a random video on some of the pieces in my electrical transformer collection. First off are these four. I got this pair of ferroresonant regulating transformers. This one's just a fairly typical, fairly typical in the sense of what it does, not in the sense of how common they are, because these aren't screamingly common. These things are north of $250,000 a piece from McMaster Car New, probably a lot more expensive from Allied, although I haven't checked. Whopping 30 volt amperes. Yeah, which is a lot for such a small transformer. That $15, by the way, is high. I probably paid more like 10 to 12. Then there's this, which is a somewhat more complicated, substantially bigger transformer. This one is 1 kilovolt ampere. One interesting thing about this guy is that the output winding is a fixed split phase 120 volt, 240 volt winding, thus the pair of 120 volt receptacles as well as a 240 volt receptacle. And what I did for load balancing purposes is I split the hot in the receptacle, so there's 240 volts between hot positions on that receptacle. If you're not familiar with that, there's a internal bonding jumper between both the hot connections and the neutral connection, so I broke the one for the hots for obvious reasons, otherwise it would short out the transformer. And also there's a main on-off switch. This one is configurable for 120 volt nominal, 208 volt nominal, 240 volt nominal, or 480 volt nominal. Input, for obvious reasons, it's configured for 120 volts. Note that I'm referring to the transformer, not the hammer. This is a more conventional isolation transformer, and this also has a split winding, which is what I spoke of. This transformer not having. What that means is that the transformer, in this case both its primary and its secondary, have a pair of 120 volt windings, and whether or not the windings is for 120 volts or 240 volts is dictated whether or not the windings are wired in parallel or in series. In this case, the primary windings are configured for 240 volts, and the secondary is configured for 120 volts. Although for this, because it's just a single input, single output, the primaries and the secondaries are more or less interchangeable. For the longest time it was a 120 volt in, 120 volt out transformer, but I already have bigger isolation transformers, like an example that I'll get to in a minute, and I needed a 240 volt step down transformer because while it was under construction, this building had mostly just a 240 volt feeder for running a 2 kilowatt space heater. Although it was only used a couple of times, I just kept the 240 volt line in for purposes of convenience, as I just use this as a step down transformer to feed lights and what have you. Last of this particular group is this. This is a 3 kilovolt ampere transformer. Like an idiot, I didn't buy both of these that were available at the place that I got this from because it was only $25, and I'd easily pay that much for the cord end plug receptacles. That's the plug for the 1 kVA ferroresonant, by the way. The plug for that was hiding behind it. Yeah, this is a 3 kVA conventional industrial isolation / step down transformer. In the case of this one, it has a primary winding that's actually a pair of 240 volt windings, nominal, but well, technically the 252 volt windings, but they're tapped at 240 volts and 228 volts. And that being wired in parallel or in series, it's good for 228 volts, 240 volts, or 252 volts in, or in series, 456 volts, 468 volts, 480 volts, 492 volts, or 504 volts. And of course 120 volts or 240 volts out, but the secondary windings for this are just 120 volts, no taps. Now in the case of this, it was wired by its previous owner so that the primary and secondary were role reversed. So you feed in 120 volts, and right now it gets 228 volts out. What I am going to do is modify the wiring so that one of the receptacles is 228 volts out, one of the receptacles is 240 volts out, and I might add a third, which is 252 volts out. That's the full use of the windings, as well as replacing the power cord with a 12 gauge one so that I can use it much closer to its rating. Because right now it's effectively limited to 1.8 kVA, because it's only got a, well, more like 1.6 or 1.7 kVA, because its got a 14 gauge cord. Actually, yeah, 1.8 kVA. I was thinking it was 16 gauge because brain shot. But yeah, these are just useful little whatchamajigs, especially that big ferro-resonant guy for running stuff, because these make very effective surge blockers. Of course, really, really tiny ones like that are really only good for instrumentation or things like telephone chargers or what have you. Generally, cost effectiveness wise, you're better off trying to find a bigger one. The thing is that the bigger ones are a lot lossier. This particular guy dissipates about 120 watts to 130 watts, no load. That's just due to the core regulation mechanism of these, meaning that the core operates in saturation, because that's in conjunction with the LC tank circuit formed by the capacitors that are in the bottom of the transformer, and an auxiliary winding that the secondary winding of the transformer is tapped off. So in the case of a ferro-resonant, the input and output really aren't interchangeable, unlike with a conventional isolating transformers. Also, these guys are stupid expensive. This guy is about in the neighborhood of $1,000 from McMaster-Carr and close to $2 from Allied. List $35. I probably paid more like $30. Factoring in the receptacles and everything, I probably have about $50 to $60 invested in this, so overall pretty good. And I also have this guy, which is an 800 volt ampere conventional interference limiting isolation transformer, although these, when you buy them, the neutral is electrically grounded in the transformer on the secondary side. So I simply broke that connection to make this a true isolating transformer. I think I've covered this in a video a couple of years ago when I got this, and another one because I have a total of 2 of these. This particular guy is just serving as an interference limiter whatchamajig for this Kotek pure design inverter. Although on subsequent readings, it looks like the output of this may be isolated, but either way, because the switch mode type potential converter isolation, the switch mode type potential converter inverters are electrically rather noisy, as opposed to something like an inverter like this, which is a true isolation transformer type inverter. Well, not really isolation, well, technically kind of an isolation transformer. This has an actual mains frequency transformer in it, but that means that this inverter is bloody heavy, because this inverter weighs something in the neighborhood of about 60 pounds. Thus the rather heavy duty screws and the rack holding it in. So I guess technically this could qualify as a transformer thing, but really it's the transformer in this case is integrated into a larger device. Of course, it also means that these are much more expensive. This one was about $1,800. This one was under $200. Well, actually, technically $199 and $1,798. Yeah, of course, it means that this kind of inverter is, knock on wood, much more durable than these. Although this is still not exactly a cheap inverter, because I only got it this cheap because it was a surplus thing, and ordinarily these are $400 to $500, because even though it's Kotek branded, which a lot of people haven't really heard of, and you can't find much information on them, they're actually made by Samlex, at least from what I can determine. But yeah, they're things, and quite useful to collect if you have uses for them, referring to transformers, all the inverters as well.